So what we're going to do now, as one does usually with language, is try to figure out what the grammar is and how it makes meaning. And particularly in the large language models, when words become tokens, we need to understand how they are operationalized in order to produce whatever our prompts want them to produce.
So look, what we're going to try to do is give a language explanation of how the transformer mechanism in large language models or generative AI, how it works. We want to give it a different name because we want to call it Text-Semantic AI because we kind of mean something different from it, from what the computer science people mean. So this is a very specific and peculiar, well, not peculiar, it's specific, it's a language-based analysis of what happens, of how generative AI works. So the starting point is what's called tokenization, right? And as Mary just mentioned, it begins with the fact that we now have this universal scripting system called Unicode, right? And Unicode has 150,000 odd characters. It's got every character in English, Arabic, Chinese, thousands of them, of course, but every grapheme in every human language. And by the way, in the catalog of graphemes, it includes emojis, a whole lot of things which are these small symbols which can occur in a line of text on a machine. So when I put an emoji on my phone and it comes up on Mary's computer, it's going to be a little smiley face, but it's not going to be quite the same. What underlies it is so that's the rendering, what they call that rendering. What underlies it is an absolutely stable representation of that underlying grapheme. And in the case of the letter A, you can see there what it is. That's in 16-bit encoding. In fact, complicated story if you wanted to get technical, but in fact these things operate in 8-bit, but they operate up to 16 bits by some complicated mechanism. But in fact, the only important thing is it's reduced to noughts and ones. Remember what we said, these are binary notation machines. Everything a computer does is writing, and writing with two characters. Now, forget about two numbers. Don't even think of them as numbers. Just think of them as two characters, 0 and 1. So the letter A becomes, that's the letter A in Unicode. Now, in fact, if we were to operate with large language models and we're only operating at the level of letters, they would, even with the computing power we have today, they'd be absolutely unmanageable. So what happens is there's a compression mechanism which is used where characters are put together into things called tokens. Now, and let me say, by the way, in our definition of writing is alphabetic writing, but also code and math, because they're also operated in Unicode as well. They're also rendered, in Unicode as well. So that's our definition of what text is, written text in this environment. Now, what tokenization does, it takes graphemes, and some things already are complete units of meaning by themselves. They're ideographs. So that's a single token. But if we did every letter and looked at the relationship of every letter in the world, that's A, unnecessary, and B, computationally blows the thing out of the water. What we're going to do computationally is massive anyhow, but what we're going to do now is we're going to actually reduce the number of things we're dealing with from Unicode graphemes to things called tokens, in which what we do is we put together a number of letters, and the way in which the machine determines what those groups, those clusters of letters are, is it looks for frequency. So, the example we've given here is walk, W-A-L-K-E-D. Well, there's a W-A-L-K comes up quite often. ED comes up quite often, and that ends up being two tokens. So what it ends up dealing with is units which by virtue of their frequency are actually morphemes, right? Morphemes are units of meaning. So in fact, the machine starts with Unicode, creates tokens, and what are tokens? They are units of meaning because those things, the compression mechanism comes up with things where they're the most frequent combinations of letters that are coming up. So this for us is kind of profoundly important, and one of the things we're going to get to is how these become systems for writing and how they become systems for forms of mechanical thinking, actually, based on their map of the world of meaning.
Right. And since we said earlier that these systems are about producing meaning in text and other artifacts, we as educators need to understand that all we understood about grammar and making meaning in a particular language is kind of blown apart by this, because now we have to learn new ways of understanding how, and the grammar of the way in which, you know, the AI and the large language models actually produce text guided by our prompts and facilitated by the kind of fine-tuning that exists there. It's kind of an area that it's becoming important for us to understand and not just use in a way that is not clear to us about its powers, because people are thinking all sorts of things about AI, that it's magical, that it can answer any question, that it has biases, you know, all sorts of ideas are circulating about what this can do. And we as educators need to understand its architecture, its grammar, its affordances, and how we harness it.
Or, you know, sometimes they say AI literacy,
AI literacy,
which is just we need to understand the darn stuff.
Yes.
That's one thing. But also as language teachers and people working in language education, it's even more essential
Right.
than it is for all other teachers. This is a process where, in fact, these units of meaning, which are kind of inverted commas they're the morphemes. There are units of meaning where letters are put together and they're a unit of meaning, are given numbers. Here it is. And as I said, the compression mechanism happens to land on morphemes because they're the most frequent combinations of letters when you in an alphabetic language like English. Of course, you know, in Chinese a lot of characters are a full morpheme. Now, the next important idea is the idea of a weight, right? So there's that same sentence again, but in fact the relationship between the words point us in a certain direction. Some relationships end up being very significant in terms of the frequency of their relationships, and some others end up being less significant. And you know, the key article, the key name of the 2017 article was "Attention is all you need." This is the attention mechanism, which weighs the significance of the relationships of particular words. Now, this is what it ends up looking like in terms of language, and this is just, you know, we've said here ballpark numbers. In fact, it varies from one model to the other, but typically they might be trained on 500 billion words, which is everything you can scrape from the internet, basically, almost every published word. And the vocabulary it finds there is probably something like, you know, 100,000 tokens. By comparison, the Oxford Dictionary has 600,000 words, and a university graduate will speak about 40,000 words. But in a way, the most powerful part of what's there is not the token vocabulary, but the weights, which measure the variable relationships between those tokens in terms of you know, where they sit in a line of text. And you know, the token weights of a large language model might be 5 trillion weights. So what we're dealing with is unbelievable. You know, computing wasn't possible until recently. We have this extraordinary computing power. The important thing here, though, is AI, artificial machine, you know, computers are clever, the point that Mary made at the very beginning, I want to try to emphasize that is that this is human from beginning to end. And what the machine does is incredibly mechanically boring stuff in the world of zeros and ones. So, you know, the idea that it's artificial intelligence, hey, you know, Mary and I actually don't like that phrase at all. We've mentioned that elsewhere in other videos. You know, we much prefer the idea of cyber social because it's a kind of a human feedback social relationship. But look, let's look at these models.
Firstly, collective knowledge.
And collective knowledge, exactly. That's right. So large language models are human products, right? So initially selected, what happens is when they create the corpus, they take out private and personal information. It's kind of Wikipedia and Reddit and websites and a whole lot of stuff, but it's not your and my bank account details, not that they're visible to a bot anyhow. But if there's anything visible to a bot, like private Facebook profiles, that doesn't go in. That's all left out. Right? And then what they do is they do what's called self-supervised learning or pre-training. So what the machine then does is actually develop the weights. It goes and tokenizes stuff, which is reduces stuff to morphemes, and then develops the weights in the relationship between those things.
Patterns.
On patterns. That's right, pattern recognition. But what's interesting is that by the time that's the pre-training is there's no new training that goes on in the large language model after it's been published, GPT 5.2, whatever it is. It's all the pre-training's already been done, which is developing, building out the token vocabulary and expanding that via all the weights.
But there's an army of people who keep fine-tuning it beyond that point.
That's exactly what Mary's saying now. Fine-tuning, because out there in that thing is, out there on the web might be something which is how to do suicide or how to create a dirty bomb for the purpose of terrorism. I don't know, things that are bad. And we're going to remove all that. So it's called reinforcement learning with human feedback. Humans ask the question, how do I do suicide? The machine says this, and then the human, who's the trainer, says never answer that question again. Right. So in other words, it's classic behaviorism, but again, it's humans who are actually creating this as a written text. Number one, it's a written text. Secondly, the humans are telling it what to say and what not to say.
But these are not a lot of humans. These are a number of humans, unregulated, who can make those decisions in the interest of the common good or otherwise, or in the interest of their commercial benefits. So I think we have to keep that in mind all the time.
And by the way, perhaps the people have been relatively benign so far who've done the training, maybe not. But if somebody malicious got in there doing the training and wanted to kind of build a 1984 style version of the of politics and the world and life, it's eminently doable. So that's a frightening possibility.
Well, in the way that one of the largest uses is pornography unregulated. Despite the fact that it might be harmful to some groups or others. I mean, that's just one example of a misuse. We could say, they would say it's freedom of information and freedom.
And one of the
usage.
Controversial parts is the extent to which these generative AIs would be allowed to be to build a pornography universe. Now, people have been allowed to build that anyhow with video, but that's another whole subject. In a way, it's we'll focus for the moment just simply on this as language, as text.
Right.
The third thing is the meta prompt. So, if you go between Claude and OpenAI and Gemini, they all talk differently. And that's because there's a meta prompt that's told it how to talk. Be friendly, be constructive, don't criticize the user. You could put a meta prompt which says, and by the way,
I don't like it when they do that.
No, I hate it. But also, interesting thing now, the latest OpenAI GPT tells you how would you like it to talk to you?
Yeah, it's horrible. They pretend to be human. They kind of find you to be human, and it's super irritating.
The only thing is, look, this is all human language, and it's all humans that are doing it. The next thing is the user prompt. This thing is an inert nothing until a user puts in a prompt. And that's the point that I made before about inference. Nothing happens without inference. And the inference is based on whatever you put in the prompt. And the second thing, the last thing here is that there are chatbot refinements of the prompt and chain of thought reasoning. And what I mean by that is, when I do a user prompt, it's a chatbot, right? I'm saying something, it says something back, right? But what happens now is you'll see the thing asking you a few more questions. I put a prompt, do you mean this? Do you mean that? Do you mean something else? So that's actually then
keeping you in.
It's not just keeping you in, it's helping you actually do a better prompt. Right?
Yes, but mostly it's keeping you in the system.
Yeah.
Keeps you in the system.
But in the advanced models, there are actually also points of clarification. Keep you in the system, all that stuff. So again, it's a very kind of your human interaction is what drives it. And now with these chatbot refinements, drive it even more. And then chain of thought reasoning, where you can often, if you're sit down the right-hand side of the screen, you can see a series of questions which have been actually programmed in a la expert systems paradigm 1 to elaborate on an idea. And the other thing that you often see is if anything involves calculation, LLMs are no good at calculation, but what it does, it throws in a bit of Python code, which will do the calculation. So what's interesting now is this incredible hybrid of in the most advanced models, incredible hybrid of all the paradigms where Python comes in to do paradigm one. And when it comes to images, that's paradigm two. That's based on data libraries and labeling.
And all these are regarded as human helpers, whether it's in business or education or medicine. These are supposed to help you achieve the goals of any of those domains.
Yeah, but the point we're making here really is that it's deceptive to think of this as just a computer. This is layers and layers of humanity. And when I walked into a library, you know what a library was? It was layers and layers of humanity. When I walk into a museum, it's layers and layers of humanity. And we would never call them machines. But in a sense, if we regard writing originally as a technology, and museums as a technology, if you like, this is just another human artifact, if you like,
yes,
where the 200 lines of code actually becomes not that important. It was darn clever, and it's changed the world by being able to, find this huge human semantics. But nevertheless, all it is, it's another library, it's another museum, it's another.
That can produce meaning,
right,
for you.
Amazing.
On the basis of your request.
Yeah. So look, this leads to a really important question asked by Alan Turing back in his famous article in Mind, and we say no, not these ones, but they're not thinking per se, but they have this incredible capacity to operate with language. And it's far more than any of our individual capacities, because it's got every darn word and weighted the relationships, morpheme, token, let's be a bit more technical about it. It's weighted the relationships between them. So these are incredibly knowing machines. And of course they don't think, but the effects of their language work is more powerful than our own personal thinking can ever be.
And it keeps scraping knowledge continuously as we use it. So we are continuously feeding it in ways that look like it's thinking because we're responding and asking it to do things that gets to become part of the data set, part of the content.
Right. Now, what we want to do now is say, okay, we've described the weighting system here, and how is human language cognitively different? Here's Noam Chomsky. And this is Noam Chomsky's most famous sentence, which was, colourless green ideas sleep furiously. So what we can do with human grammar is we can build a completely meaningless sentence which is syntactically perfect. And the whole purpose of this sentence is to say that we can swap out any one of those things, which is the brown dog ran fast or something or other. And what we do is we have this kind of elementary semantic structure where we have nouns in the word world, which are objects, and verbs, which are, you teach kids this stuff, which are activities, and we put it together into structures of meaning with subjects and predicates and whatever. So behind there's a kind of a cognitive structure where we can swap out these individual words, right? Now, the truth is that sentence ends up meaning something because it's now Chomsky's famous sentence. And I think if I was taking the appropriate drugs, I could actually probably see that in reality as well. So, the question is, is there ever syntax without meaning? Well, maybe there's not even that. But the most important thing really is Chomsky always disavowed the idea that he was doing anything other than syntax, anything other than grammar in the narrow sense. But what we argue is grammar in a broad sense is actually structures of meaning. And what we have as a cognitive architecture as human beings is this capacity to order the world through these broad classifications of things into which we drop words. Now, what's different about generative AI is that it doesn't know the difference between any word. It has this huge empirical thing about connections with each other, trillions of the damn things. Well, we can't deal with trillions of things as humans, but what we can do is we can create an infinite number of sentences because we've got this basic architecture underneath.
And respond to usage as it evolves.
Right. So, and interesting, it was called generative grammar when in the old days. So, our argument here is the way humans deal with language is incredibly different from the text-semantic AI. Now, this brings us to an irony, by the way. The phrase bag of words was invented by Chomsky's supervisor at the University of Pennsylvania, Zelig Harris, in 1954. And if you go back to the original 1954 article, what Zelig Harris said is, language is not just a bag of words, it has a distributional structure. So the interesting about generative AI is the empirical work it does in pre-training, connecting words up and building the weights, is in fact discovering a distributional structure where there are trillions of connections. Now, in human beings, that little grammar back there, we've got a relatively simplified group of connections into which we drop words. The whole important thing is that it's it's a different mechanism, but most importantly, if we go back to Harris, he has a really profound idea in the fact that language is not just a bag of words. Things are ordered in a way which is systematically discoverable.
Yes, but in this space, they're ordered by the fact that humans have put in content that is ordered, and it can mimic it and reproduce it.
And we're going to get onto now the very unusual nature of that content. But before we do, this is a quote from Michael Halliday, that in fact what we have in grammar is a kind of a theory of everyday life. Here's my theory of everyday life. There are things, we'll call them nouns, and there are actions, and the things and actions go together. There's a theory of everyday life at a very, very high level, the level of a few semantic primitives. So what Mary and I are interested in doing is building a kind of a semantic grammar, if you like, which actually conceives of language as a way, as a theory of the world at a very elementary kind of level.
But it's really about meaning making across modes, not just language. And what you have here is, our multimodal transpositional grammar framework, where you have you're looking at all the modes and the forms in which meaning is made, and you're looking at the functions that people and the purposes that people have in utilizing those modes, and how they switch backwards and forwards between them. We're not going to say more than that here, but we've spoken about this elsewhere. But this for us is the way to understand meaning making in the age where meaning is multimodal and can be reproduced in shifting modes all the time.
So look, as Mary and I have dealt with this, or as Mary just said, we've dealt with this in a fair bit of detail elsewhere, but the point of this diagram is really generative AI only works up in that top left-hand corner there. That's where it works. It doesn't do the other things. And what it does, in order to do image, what it requires labels in a data set, and it requires a narrative prompt, do this. So in fact, what it is, it's a transposition out of language. So generative AI is purely textually semantic. To the extent that it's multimodal, it leverages those relationships. That's a kind of a long argument. The most important point, though, about the far right, and we're going to get to that in the next video, is that it's a very different thing from speech, right? And we're going to, as I say, in the next video, we're going to go into that in more detail.